In this video, we're going to complete example 3 and we're going to learn how to change the subject of a formula. Now we've got 4 questions that we're going to cover, questions A and B, and on the next slide, questions C and D. Now before we get into these examples, I just want to first explain what it means to change the subject of a formula. Now my first question to you is, do you know what a formula is? Well, a formula is basically an equation. Now, a really simple equation that we've looked at is 2x plus 1 equals 5. And we know that this is an equation because it has 2 expressions, 2x plus 1 and 5, that are separated by an equal sign. When we look at our formula v equals u plus at, we have 2 expressions, v and u plus at, that are separated by an equal sign. So what makes formulas stand apart from equations? Well, formulas are used for specific purposes. This particular formula is a formula used in physics to calculate velocity. Now, when we have a formula such as v equals u plus at, the v is referred to as the subject of the formula. That's because it's on its own next to the equal sign, and all the other pronumerals are on the other side of the equal sign. So if we wanted to calculate the velocity of something, I would use this formula because v stands for velocity. But what if I wanted to calculate u? U stands for initial velocity. That means I want to change it so that u becomes the subject of the formula. How do I do that? Well, I'm going to follow the same basic rules that we use when solving equations. What are these basic rules that I'm talking about? Well, these are rules that I discussed in earlier videos, and I'll just remind you of them now. So when solving linear equations, some useful rules or tips that I gave are to add or subtract both sides by the same number or expression, to multiply or divide every term by the same number or expression. I also mentioned that brackets are a pain to work with and that you can fix this by expanding the brackets. I also mentioned that fractions are a pain to work with and that we can fix this by simply multiplying. Now, if you don't know how to solve linear equations, then you are not ready to learn how to change the subject of the formula, and you need to go back and learn how to solve equations before you finish watching this video. Now, coming back to this formula, we want to change it so that the subject is u. Now, one of the rules or tips that we learned when solving equations is that you can add or subtract both sides by the same number or expression, and that's what we're going to do here. I'm going to subtract the same thing on both sides of the equal sign. I'm going to subtract at because that's going to isolate u and leave it on its own on the right side of the equal sign. Now, what do I get when I take v and subtract at? Well, I'm simply going to write v minus at. And I've now changed the subject of the formula so that I can calculate u, or my initial velocity. Now, I've given a couple of pointers here as dot points. The first one just says move all terms containing the subject to one side of the equal sign, and that's what I just did. I wanted to make u the subject, and I kept that to one side of the equal sign and moved everything else to the other side. The second dot point mentions that factorizing is a great way to extract the subject from other numbers or pronumerals. And we'll talk about this in more detail as we get into the examples. So let's get right into question A. You'll notice that we're told to rearrange each formula so that the pronumeral in square brackets becomes the subject. So for question A, we want to make B the subject. So how are we going to do that? Well, you'll notice that we've got 2 terms. We've got the a, and then the fraction on the right is our second term. So I'm going to follow the rules that I follow when I solve equations. I'm going to multiply both terms by 2. And I'm doing that because it's going to cancel the 2 below, leaving me with a times 2, which is 2a. Now I need to point out that this is a capital A and we also have a lowercase a, which means they're two completely different pronumerals. I've got to keep the capital A as capital A and the lowercase a as lowercase a. Now I've cancelled the 2's on the right, so I am now left with h bracket a plus b. You may have also noticed that the first thing I did was I got rid of that fraction, and I've mentioned before, if you've got fractions, get rid of them. The other pointer I gave when solving equations was to get rid of brackets by expanding them. So we're going to do that next. So h times a is just ha, and h times b is hb. And then I've got 2 capital A to the left. Now I'm trying to make b the subject of the formula, which means I'm trying to isolate the b here. I want to get rid of the ha first, and that's not difficult. I can just subtract ha on both sides of the equal sign because that's just going to cancel it, leaving me with 2 capital A minus ha on the left and hb on the right. Now I'm still trying to isolate this b here. I need to get rid of the h, which is really simple. I just need to divide it by h, which means I have to divide every term by h. So I've got to divide ha by h and also 2a by h as well. This will cancel out the h next to the b and also cancel out the h next to the lowercase a, which leaves me with 2 capital A over h minus lowercase a equals b. And we've now changed the subject of the formula because b is on its own on one side of the equal sign. It's also best practice to have your subject on the left side. So we'll rewrite this again where b is on the left hand side, and whatever was on the left hand side we're just going to rewrite it again except on the right hand side. So that's question A done now. Let's move on to question B. This time we're trying to make y the subject of the formula, and as I've mentioned lots of times, when you've got fractions, get rid of those denominators first. It just makes your life so much easier. Now I'm not going to multiply by 4 and 2 and 3. I'm just going to multiply by 12. And the reason I'm multiplying by 12 is 12 is the same as 2 times 6, multiplying by 2 and 6. It's also the same as multiplying by 3 and 4. They're all 12. They're all the same. And the reason I'm doing that is for my first fraction y over 4, I would pick this one. I would multiply by 3 and 4 because I want to cancel that 4. I'm going to multiply by 3 and 4. And also the last fraction, I'll multiply that by 3 and 4 as well because that's going to allow me to cancel the 3 out. Whereas the fraction with the 2, I'm going to pick 2 times 6 as my multiplication, because that's going to allow me to cancel out the 2. Like I said, I'm really just multiplying by 12. 3 times 4 is 12 and 2 times 6 is 12. They're all the same. So looking at my first fraction, the 4's are going to cancel like so, and I'm just left with 3 times y. So that gives me 3y. Looking at the second fraction here, the 2's are going to cancel, which really just leaves me with x times 6, or 6x. And now looking at my final fraction, the 3's are going to cancel, and I'm left with 4 multiplied by y plus 1. Now, y plus 1 needs to be put in brackets before we multiply it by 4. And the reason for that is we're multiplying the whole expression, y plus 1, by 4. The next pointer I gave is whenever you have brackets, you need to expand them because brackets are a pain to work with. So we'll start there. 4 times y is 4y. And 4 times 1 is 4. So plus 4. The left-hand side is going to remain the same. Okay, now we're trying to isolate y. We're trying to make y the subject of the formula. So I want to have anything with a y in it to one side of the equal sign and everything else on the other. Now usually my next step would be to subtract 4y to get rid of the 4y on the right side and subtract 4y on the left. But that's not going to work that well because 3y minus 4y will give me negative y. I think it's going to be better to subtract 3y and cancel out the 3y on the left-hand side. Why am I doing that? Well, 4y minus 3y is 1y, or just y, which is great. It means I'm not getting a negative. I've also got my plus 4, and I've also got my minus 6x. Now, I'm really close now. I want y on its own. All I have to do is subtract the 4 on both sides of the equal sign. That's going to cancel my 4, and I'm left with y on the right-hand side. What do I do with negative 6x minus 4? Well, I just write it the way it is, negative 6x minus 4. And now I have made y the subject of the formula. Now, I would like to have it so that y is on the left-hand side. It's just best practice. And there is one more step that I can do, I don't have to do. Because these are both negative, I can factor out that minus sign if I so choose to. I can write it as y equals minus, and in brackets, 6x plus 4. This extra step is more for advanced users. You don't really have to do that. Alright, moving on to question C now. Once again, we've got fractions. We don't like fractions. They're a pain to work with, so we need to get rid of the A, the B, and the C. What that means is we have to multiply everything by A, B, and C. And when I say everything, I mean every term. So I've got to multiply this term by A, B, and C, and also the last term by A, B, and C. So we'll start with the first fraction. When I multiply by A, B, and C, the A's are going to cancel, and we're left with 2 times B times C. That's just 2bc. Looking at the second fraction, we've got a denominator which is b, so the b's are going to cancel. We're left with 1 times a times c. 1 times a times c is just ac. So minus ac. And for the third and final term, the c's will cancel, leaving us with 5 times a times b. So I'm going to get 5ab. Now remembering that we're trying to make a the subject of the formula, I have two terms here that have an a in them. So I want to move them to one side of the equal sign. The 2bc doesn't have an a, so I want it on the other side of the equal sign. I feel that the best way to do this is to add ac to both sides of the equal sign. The reason I'm doing that is it actually gets rid of a negative, and I don't particularly like working with negatives if I can help it. What does that leave me with? Well, I've got 2bc on the left, and then I've got 5ab plus ac on the right. Now we're in a position where most people get really stuck because we've got two terms that have an a in them. And when you get into this situation, the best way to fix this problem is to factorize. And we're going to factor out the a, and you'll soon see how well this works. So the left side is going to remain as 2bc, and we're going to factor out the a for the right hand side. A times 5b will give us 5ab, and a times c will give us ac. Now that we've done that, we simply divide what's in the brackets. We're going to divide by 5b plus c, and we're going to do it to both terms. Why are we doing that? Well, that's going to cancel the 5b plus c that's in the set of brackets, leaving me with the subject on its own, which is what we want. And then on the left-hand side, of the equal sign, we're going to have 2bc over 5b plus c. Now technically we're done, but it's best practice to have your subject on the left side of the equal sign. It's not a big deal to change it like so. Alright, now moving on to question D. This time we need to make h the subject of the formula, and as I've mentioned many times, when you have a fraction, you need to focus on getting rid of that fraction first. So I'm going to multiply both terms by h minus 3. Now I'm going to put that h minus 3 in brackets. The reason I'm putting the h minus 3 in brackets is because I'm multiplying by the whole expression, h minus 3. So it needs to be put in brackets. That's going to cancel the h minus 3 below. And on the left-hand side, we've got g times h minus 3. I'm going to write that as g h minus 3 like so, equals h plus 2. Once again, one of my pointers was that brackets are a pain to work with. If you get brackets, you should expand them straight away. G times h is gh, and g times 3 is 3g. So we get gh minus 3g equals h plus 2. Now, because we want h to be the subject of the formula, we're looking for all terms with an h on them. We want them to one side of the equal sign and everything else to the other side. So what I'm going to do first is I'm going to subtract h on both sides. That's going to cancel the h on the right, leaving me with 2 on the right-hand side. What am I going to have on the left-hand side? Well, I've got gh minus 3g minus h. gh minus 3g minus h. I really want to get rid of this 3g because it doesn't have an h in it. So I want that on the other side, the side without h's. I'm just going to simply add 3g to both sides of the equal sign, like so. That leaves me with gh minus h on the left and 2 plus 3g on the right. Now, we really need h on its own, and I mentioned before, if you get stuck, you probably need to factorize. We're going to factorize the h because the h is what we want to make the subject. So if I factorize out the h, what goes in the brackets? Well, h times g will give me gh, and h times 1 is h. The right-hand side will remain the same. And now it's quite simple. If I want h on its own, I need to just divide every term by g minus 1. Like so. That's going to cancel out my g minus 1. And then I'm left with h on its own. And the right-hand side is already written here. 2 plus 3g over g minus 1, and we now have h as the subject of the formula. Before we conclude this video, let's summarize everything that we learned. First of all, when changing the subject of the formula, you use the same rules that we learned when you solve equations. And we emphasized getting rid of fractions and getting rid of brackets first. Once we had done that, we tried to move anything with the subject to one side of the equal sign and anything without the subject to the other side of the equal sign. And then, quite often we had to factorize and then divide in order to come to our final result. Anyway, that concludes our video on example 3. Remember to read the description below for links to workbooklets that relate to this video.